Hello, this is video 3 in your quantum linguistics section, and actually today we're going to be talking about quantum physics, because in order to really understand NLP generically and the law of attraction, it's really useful if you have a basic understanding of quantum physics. And you know, you will hear me talk all the time about the universe and energy, and you may think this is because I'm a giant hippie, which I probably am. And yet, the law of attraction is often perceived as something spiritual or something from the realms of mystery or magic. And also, because so many of us have difficulty with the concept and the actual practice of law of attraction, it's really important, I think, for us to look at it to understand what it really is. And actually, it is firstly, it's the science of deliberate creation. However, the law of attraction is actually just another name for some of the principles from quantum physics. It is science rather than a mystery. And the fact is that whatever your mind can conceive, it can create. And that's all very well, because obviously so many of us have had challenges to actually work with the law of attraction and to achieve what we really want, or perhaps we've had outcomes that weren't what we expected. So I think if you can really understand these concepts, and I'm going to try and explain them really simply, and how they work in my head, which hopefully will translate easily for you, it will actually really help to empower your use of deliberate creation, your use of deliberate thinking. So, in order to really understand quantum physics, we have to go a little bit back in time, and I want you to think back to when we believed that the Earth was flat. Renaissance science. So, this was before the first scientific revolution, and we also believed many other interesting things that we might laugh at today. However, it's just obviously we have more knowledge. So we believed that the Earth did not move and that the Sun moved around the Earth or orbited around the Earth. We also believed that blood did not circulate through our bodies. Oh, apologies, there's an error on that slide. It did not circulate through our bodies. And we also believed that matter was made of one of 4 elements, either earth, air, wind, or fire. All of this is going to give you a little bit of understanding into some societies, how we still operate and use this earth, air, wind, fire elemental healing, elemental thought patterns. You can look at the Chinese society, for example, feng shui, which operates very much around these 4 elements. So in the Renaissance era, it was really, really restricted in terms of thinking, and pretty much anything outside of law or theology or medicine, and medicine, by the way, included maths, or the arts, was considered to be old-fashioned magic and very, very naughty. Now, how is it important for you to know this? Well, I think it's really important to understand how developments have occurred and just how risky it was for people to develop, because if everything was considered, very naughty outside of these 4 disciplines, then actually people were putting their lives at risk in order to think differently or present different ideas. So, the major issue with pre-classical physics or Renaissance physics was the fact that they followed the principles of Aristotle, and as a result they didn't believe in experimentation. Okay. So as you look at this slide, I also want you to think about the restrictive structures in the thinking and how this is carried through today. Okay, so what happened next? Well, in the 1600s, classical physics was developed. And this is referred to as the first scientific revolution. And it was fathered by the likes of names you will find very familiar, Newton, Kepler, Copernicus, and Galileo. And they did such advanced work that actually, by the late 1800s, it was thought that really all the interesting work in physics had been done, and there was no other major question to be answered, which was quite interesting. And what's really interesting about classical physics is the fact, because it was such a major shift or paradigm shift in thought patterning, actually everyone was so wowed by it that it created the foundation for all elements of modern society. It created the structure for our social structures, our organizational structures, and personal paradigms. So think about this in relationship to values work, and whether you're talking about Graves' values, whether you're looking at Maslow, whether you're looking at other evolutionary processes or analysis, just think about this for a minute. So really, even today, because we're only 100 years into quantum physics, we're still structuring our societies on classical physics. So if you're in a Western society, then effectively the awareness you have of the material world is almost entirely based on classical physics, and classical physics is what you learn up to the age of 16 in school. And really, it's 17 and 18, they turn around and say, hey, forget everything you learned in physics, let's talk about quantum physics, it's completely different. So you probably want to have an idea of what the concepts of classical physics are. Well, it's pretty simple. The idea is that the universe, or any material object, operates a bit like a big machine, a bit like a big clock. It has lots of tiny, tiny interactive parts which operate in harmony. When I visualize this, I think about a giant watch with all the cogs turning and working. And as you think about this, I'm wondering if it reminds you of societal structure in any way. It also suggests that every part has a very few and simple properties and movements based on only two different things. One, the mass of the part or object, and number two, the forces acting upon those parts. Now, for a long, long time, classical physics worked absolutely perfectly, and it must have done, because everyone was basing, political systems, philosophers, social structures, psychologists, they were operating from these, or from the foundation of these classical physics concepts. So what changed? What happened? And when did it happen? Well, in 1887, two guys did a little experiment. And Albert Michelson and Edward Morley conducted an experiment to understand how the Earth travelled in space. Okay, so they were busy conducting this experiment trying to understand how the Earth travelled through space. Now, classical physics had decided that half the year the Earth was moving towards the Sun, and the other half of the year, the Earth was moving away from the Sun. So what they proposed is that the speed of the Sun's rays should have varied or changed based on any change in the position of the observer. So obviously, as they move towards the sun rays should have changed. And they spent an entire year running these experiments, and they had a miraculous discovery, and their experiments proved that the Earth travelled at 0 miles per hour. Yeah, that's right, 0 miles per hour. So, obviously, they thought to themselves, this cannot be correct. And this is such a famous experiment because it is considered to be the one experiment that actually kicked off the start of the second scientific revolution and the discovery and development of quantum physics. And we should probably talk about some of the major rules of quantum physics. And this is where it should get a little bit interesting, or I hope it'll get a little interesting for you, because the first one is something called holism, where living matter or material reality is made up of organic or unified wholes that are often greater than the sum of their parts. Sound familiar? The second one, cause and effect. There is not necessarily a relationship between cause and effect. Action is not always caused by another force exerting itself. Interesting. So what is it we do with language? We break A leads to B, which is, guess what? Cause and effect. Okay, the third rule, the observer and the observed cannot really be separated. So the observer and observed cannot be separated. Observers' expectations and observations become literally a part of what is being observed. They are considered two different perspectives of the same thing. And this is actually in physics or quantum physics called the observer principle. And if you're familiar with a book called In Search of Schrodinger's Cat, I've talked about it a lot, it's a really good book. Schrodinger conducted or talked about a perceived experiment of putting a cat in the box and putting it in the woods. And this demonstrates the observer principle perfectly. Okay, the fourth rule, lost my ability to speak, is that systems are not linear. They are equations which are not proportionate to their causes. There is a lack of logical sequence, correlation, and cohesion where once before we thought it was ordered. So I want you to ask yourself, how does this relate to time? In fact, how does this relate to anything? Think about it. Ask yourself, can you see it? Can you see how the entirety of NLP was actually structured around these four concepts of quantum physics? And I want you to think about how interesting it is. It's no wonder we're obsessed with time if everything is based on classical physics. Still now, we're 100 years in to even beginning to apply some of these quantum physics theories across the world. It's still so new, and this is why we're still operating so much of our thinking, so many of our functions, all based on the old style classical physics. Interesting. What interests me most about this is it's no wonder that we have issues with the law of attraction, because if we're still operating in a very linear world and most of our thinking still stems from classical physics, how is it possible for us to do this paradigm shift, which requires a massive leap of faith into the law of attraction? Good question. So I'm interested in your feedback on this, and this is the first quantum physics presentation. We've come to an end of it. I'm trying to keep them short because I want to give you time to think about these concepts rather than overload you with a ton of stuff. And I'm going to talk more about quantum physics and what it means in the next presentation. Have a lovely day. Bye.